Hi, and welcome to Mrs. Ballard's class. Today we're going to be talking about calculus topic 1.16. And we're going to be working with the intermediate value theorem. So this is something kind of totally off the topic of what we've been doing the rest of the unit, but this is the first place where it fits in, and we will revisit it again later in the curriculum. The lesson objectives, or the essential question, is how do we apply the intermediate value theorem? And then you're going to write down actually two I can statements today. I can apply the intermediate value theorem to find a zero, and I can apply the intermediate value theorem to find a C value, and that's going to make more sense when we actually do it. As always, if you need to pause for some extra time to write things down, that's fine, or you can always rewind if I go a little too fast. Okay, let's go ahead and take a look at this. All right, here we go. All right, if you have not read through this first activity, so my suggestion is you take a few minutes and you read through that activity right there and you try it. So I pause, and it might take you like 5 minutes or so. Give it a good 5 to 8 minutes of reading through those problems and answering those questions. It really isn't that difficult. I'm going to pause for just a minute, and then I'm going to start kind of talking through that right there. So as always, we want to make sure that we have written our name on here. So just make sure that you've added your name up to the top there. And I'm going to do something a little bit different today. I am going to try to type some of my answers here. It's not liking it because I'm using the pen instead of the cursor. All right, so the activity here talks about being an Uber driver. So Uber is a ride-sharing service operated by 785 metropolitan areas worldwide. Their mission is to make transportation accessible to everyone. You would have just begun employment as an Uber driver in New York City. So I'm sorry, I did not change the example for California, so we're going with New York City. What are some things you have to think of as an Uber driver? So some things that you could have possibly come up with, maybe you have to think about paying for gas, insurance, maybe who you're picking up, the route you have to travel, maybe traffic, speed, you have to pay for maintenance on your car. Okay, so those are just some of the things. There's probably plenty of others. Those are just a couple ones that I brainstormed. All right. When you pick up your first group of tourists, your odometer reads 0 miles. I, of course, spelled this wrong. Does it give me a choice? No. Nope. All right. It reads 0 miles. So this right here would be considered your Y value. Okay. When you drop them off at the Statue of Liberty 40 minutes later, so 40 minutes, the miles is the Y value, the minutes is the X value. It reads 17.5 miles. Must there have been a time during the trip when your odometer read 8 miles? Well, if we think about that, is there any way that I could have possibly skipped over the number 8 when I go from 0 miles to 17.5 miles? And there isn't a way to do that. So must there have been a time during the trip when you read 8 miles? So the answer is yes. You can't skip 8 miles and get to 17.5 miles on the odometer. Now, a little side note on that, okay? So this is something else. If you wrote that down already, this is something else you probably want to add to it. The distance is a continuous function. So 8 is guaranteed on the odometer between 0 and, let me try to write that, between 0 and 17.5 miles. I don't know if it'll let me change the color. Let's try. There we go. I'm just going to go with my misspelled maintenance word. In fact, I want to change this to something totally different because this is kind of like my commentary on it, huh? All right. Probably can't read that now. All right. So at 3 p.m., you were hired by a group of teachers to take them from Long Island to MoMA, the Museum of Modern Art, which are 50 miles apart. You drop them off at 4 p.m. So is it possible that at some point on the trip you were 53 miles away from MoMA? Explain. So what do you guys think about that? If you had to have taken an alternate route, which may have gotten you there faster because of traffic, it is possible. So yes, it's possible because you may have taken an alternate route. Okay. And then a little bit of commentary on that is that you aren't necessarily guaranteed to be in this interval. So you're not guaranteed because the 50 or the 53 is outside. Oh, never mind. Don't listen to me yet. Let's do B and then we'll make the commentary on this one. Must there have been a time when you were 53 miles from MoMA? So did you have to do that? And the answer is no, right? You could have gone straight there. So my extra little addition to this is that 53 miles isn't guaranteed. You are guaranteed everything between 0 and 50, but not 53. So 53 miles, not guaranteed distance on our interval from 0 to 50. Okay, I could highlight that and make it pretty colors too. I'm going to start with blue, and then the green, the green. With the pretty green from down there. There we go. Okay, and then finally, during your 8-hour shift, you made 12 Uber trips. Your first trip has 2 passengers and your last trip had 4 passengers. Should we assume that one of your trips had 3 passengers? Explain. Well, the passengers aren't guaranteed in between things. So that's not, the number of passengers isn't a guaranteed item. So I would say no. The number of passengers isn't guaranteed. And then my little commentary is that the number of passengers is not a function of time. And not continuous. So we can't predict it. All right. Let's see. No, continuous. There we go. Okay, so this. That one's green. This one's blue. All right, so basically what that little example was to show you is that this is an illustration of what we call the intermediate value theorem. In layman's terms, the intermediate value theorem basically means that as long as our function's continuous and we have a closed interval, we are guaranteed all those y values within that interval, okay? as long as we have that happening. So these were some examples. The odometer was an example of the intermediate value theorem because it's got to be continuous and you can't skip over the miles. Okay. But you have to be, we also saw the example here where you have 53 miles, you could do it, but it isn't guaranteed. The guaranteed distance is between 0 and 50. All right, so let's actually formally write our intermediate value theorem out here. So I'm going to flip my computer a little bit here now that I'm not typing. And it's going to feel like English class today. There's a lot more English writing today. So one of the first important existence theorems we will study in calculus is called the intermediate value theorem. Like all existence theorems, we will study the IVT relies on the continuity of a function, and that's super important for our function to be continuous. So if f is continuous, and that is so important that I would make sure I highlighted, bold, starred that word, okay? On a closed interval from a to b, and k is any number between f of a and f of b. So basically it's saying that these are the x values here, then this other number here is some number that's between these y values. So those are the y's right there. There is at least one number c in a and b such that the y value, the f of c equals that number k that's between these two y values. And you can kind of see the picture illustrated here. I know we did a kind of an example, but basically if I have these two x values, a and b, and my function is continuous, I know that I have to cross this y value right here at some point if I'm going to be between these two values. And you'll notice here that doesn't work because the function is not continuous. All right, so let's go ahead and try some of these examples. We've got the function f of x is continuous on the interval from -3 to 9 with f of -3 equal to 0 and f of 9 equal to 12. Which of the following could be a correct statement concerning the existence of a value c by the intermediate value theorem for the function f of x? Well, first of all, we know that f of x is continuous, so f of x is continuous. That guarantees that the intermediate value theorem works. Let me rewrite that a little bit there. So I would write, therefore, by the intermediate value theorem, it guarantees a value c on 3 to 9 such that it's between the two y values. Well, they gave us two y values, didn't they? Such that 0 is less than or equal to f of c is less than or equal to -12. I don't think that is in the right order, do you? So I think that it should actually be the other way around. It should be from -12 to 0. So I have to figure out a number that's between -12 and 0. So if I'm looking at these y values here, I'm looking at 0, which is not necessarily between, okay? 13 is, -13 is definitely not between, -10 is, and and 1 is not between. So those ones are out. So what's the difference between A and C? Because A is kind of in the interval, but it's on the edge. But let's look at the x values now. So do you see how this x value, the x values we had to be between were -3 and 9. And do you see how the 12 is not in between those values? So that means that that's the reason that that one's out. So it's got to be answer choice C. All right, so now we're going to use the intermediate value theorem to show that the polynomial function f of x equals x cubed plus 2x minus 1 has a 0 on the interval from 0 to 1. So whenever you do these problems, the first thing you need to do is state that the function is continuous, and it should be. If it's not continuous, then you cannot use the intermediate value theorem on this. So we know that this is a polynomial, so it's continuous because it's a polynomial. So you just say f of x is continuous. And you can even say, since f of x is continuous, the IVT guarantees. We're going to kind of have a sentence frame that we're going to get really good at. Guarantees at least one c-value on the interval from 0 to 1. And really what's going on with that is that it changes signs on either side of c, so such that f of x changes signs on either side of that c. Okay, so we're supposed to be showing that we have a 0 here. So what I really need to do is I need to calculate what these values, the y values are that match these x values, and the interval is always in x values. Okay, so I'm going to do those calculations. So f of 0 equals 0 cubed plus 2 times 0 minus 1, which is -1. And f of 1 equals 1 cubed plus 2 times 1 minus 1. So these 1's are going to cancel, so we would get 2. And notice that 0 is actually between those, so we're going to make that statement. So we know that we've got f of 0 equals -1 is less than 0 is less than f of 1 equals 2. So therefore f of c, equals 0. So therefore there must be a c such that f of c equals 0. All right, let's take a look at another one here. Okay, so we are supposed to explain why the function has a 0 in the given interval. So the very first thing you want to do is state that if your function is continuous. Again, we have a polynomial in example 3, so I'm going to state that it's continuous. So since f of x is continuous, the intermediate value theorem applies. Okay, and then or continuous, I really should have written the interval, continuous on 0, 1. And then I really should do this calculation here and put these x values in and see what the y values are to see if I have, because again, we're looking for a 0. So f of 0 equals 0 cubed plus 3 times 0 minus 2, which is going to be -2. And f of 1, is this the same problem? Nope, it's a slightly different problem. Okay, f of 1 equals 1 cubed plus 3 times 1 minus 2. So let's see, 3 plus 1 is 4, minus 2 is 2. So basically, is 0 in between those? Absolutely. So now we need to make that statement. Sorry. So IVT, and so you could go ahead that IVT guarantees. I don't like the way I'm writing that. Let me fix that up. Let's add this stuff in first. Okay, so let's say that f of 0 equals -2 is less than f of c equals 0 is less than, not less than or equal to, f of 1 equals 2. Therefore, IVT guarantees at least one c value such that f of c or x equals 0. All right. Let's take a look at the next one here. So first thing we have to do is show that the function is continuous, but you'll notice there's a value we can't have in there. X cannot be equal to 0, and that's in the interval. So therefore, we can't use the intermediate value theorem because f is not continuous. So on this one, f is not continuous. Therefore, IVT does not apply. Easy peasy. Like them all like that. They won't be, but like them all like that. All right, let me check this out here. Okay. So now we have a function. So this is kind of the same question over and over. They're just going to phrase it differently. So I tried to give you a whole bunch of different possibilities here so that you had a lot of practice and a lot of different examples. So excuse me, the function h of x is continuous on the interval from -3 to 7, with h of -3 equal to 10 and h of 7 equal to -2. Is there a guarantee that there is some value a in the domain such that h of a equals 1? Anytime we do an existence theorem, the answer is always yes. So yes, there is a guarantee. So yes, since h of x is continuous on the interval from -3 to 7, and you could go ahead and do the calculation here, or they gave us the calculation, and h of -3 equals 10, and h of 7 equals -2, and I'm going to write it slightly differently this time. The IVT, intermediate value theorem, guarantees there is some value such that h, and they give us the letter a, so I'm going to use that, h of a equals 1. So they said 1. Let's just double check. Is 1 between 10 and -2? It definitely is, because -2 is less than 1 is less than 10. I wrote a little differently. You get the idea across, though. All right, so now we're going to verify that the intermediate value theorem applies to the indicated interval and find the value of c. So we actually have to find the c value. So we're going to do kind of the little proof first, and then we actually have to calculate the c value, which was our second I can statement tonight, or today. So we're going to start by saying, first of all, is it a function continuous? So yes. So since f of x is continuous on 0 to 3, and let's go ahead and do this calculation. I'm going to do my calculation off to the side. F of 0 equals 0 squared minus 6 times 0 plus 8, which equals 8. And then f of 3, so I'm plugging my x values in, 3 squared minus 6 times 3 plus 8. And when I add all of that up, I get -1. And just double checking visually, is the value that they want 0 in between those? Absolutely. So, and f of 0 equals 8, and f of 3 equals -1. The IVT guarantees that f of x equals 0 for some value of c, because it's between -1 is less than 0 is less than 8, the y values. Now, I haven't finished yet because I have not yet answered find the value of c, so I'm going to do that next. So what I'm going to do is, if it basically says I'm going to take this guy and set it equal to that y value there. So x squared minus 6x plus 8 equals 0. Looks like a good old magic x to me. So two numbers that multiply to 8 and add to 6. I'm thinking 4 and 2 looks like they both need to be negative. Okay, and then we use good old zero product property. So x equals 4 and x equals 2. Now, to get our actual c value, we have to double check to make sure these are actually on the interval that was given. So 4 is not between 0 and 3. So 4 is not our c value. Our c value is this 2 because it is on the interval. So c equals 2. And I'm just going to write a reason. You don't have to. But this, I would write this down for your notes because 4 is outside the interval from 0 to 3. All right, we're going to keep going. So we are we're verifying again, and we're finding the c-value. So it's another one we're finding the c-value. So I'm going to go ahead, and I know I've got to do this calculation anyway, so I might as well just do it at the beginning. So I've got to put in f of 5 halves. I'm putting 5 halves into this mess, which is truly a mess. So we've got 5 halves squared plus 5 halves over 5 halves minus 1, which is really, I could rewrite as 2 over 2. 5 halves squared is 25 fourths, and I'm going to make this into fourths, so that would be 10 fourths over 3 halves. This equals 35 fourths. And then instead of leaving this down here, I'm going to flip and multiply in the same step here. And it looks like 2 can go into 4 twice, so I've got 35 sixths, which if I take 6 and go into 35, it goes in there like 5 point something times. All right, let's put in the other value. So f of 4 equals 4 squared plus 4 over 4 minus 1. Much nicer numbers, so 16 plus 4 over 3, which would be 20 over 3, which this is like 3 goes into 20, like 6 point something times. So what value were they looking for? They wanted us to get 6. So 6 is definitely between 5 point something and 6 point something. So we know that this is going to work. So first thing we state, we have to be continuous in the interval because we know that it's not continuous at 1, but 1 is not in between 5 halves and 4. So with the interval we have, it is continuous. So since f of x is continuous on the interval from 5 halves to 4, and f of 5 halves equals 35 sixths, and f of 4 equals 20 thirds, the IVT guarantees f of x equals 6 at some point c. Actually, f of, some point c, because I'm just going to go 35 6 is less than 6 is less than 20 thirds. Now again, that's the first part of it. We still have to find the value of c. All right, so I'm going to take this guy and set it equal to 6. So I've got x squared plus x over x minus 1 equals 6. I'm going to take this and multiply it to the other side. So x squared plus x equals 6 times x minus 1. I'm going to distribute. So 6x minus 6. And it looks very quadratic to me, so I'm going to move both of these to the other side. So I keep the x squared. When I subtract the 6, I get negative 5x. When I add the 6, I get plus 6 equals 0. Good old magic x problem. So two numbers that multiply to 6 and add to negative 5 would be 3 and 2, and it looks like both negative. So x minus 3 times x minus 2 equals 0. Get out the good old zero product property. Set them both equal to 0, so x has to equal 3 and x has to equal 2. Let's see, is our c value, are they both valid for our c value? Well, 5 halves, isn't it 2.5? The same thing, 2 goes into 5, so 2 is not in between there, but 3 is. So c equals 3 because 2 is not in the interval between 5 halves and 4. All right, one last problem here, and I want to make sure I show you this one. Oh, maybe not. I think there's 2 problems actually. There are 2 problems left. So I want to show you example 8 for sure because your assignment's going to come a lot out of Delta Math. So I want to make sure you know how to state this in Delta Math. So the function f of x is continuous in its domain between -9 and 9. Given that f of 2 equals -5 and f of 7 equals -2, determine what conclusions can be drawn based on the intermediate value theorem on the interval from 2 to 7. So we basically need to state that it's continuous. So we would say since f of x is continuous, and you'll have to put that word in there because they gave it to us, on whatever domain they give us, the IVT can be applied. And a lot of this is like drop down stuff you can just put in. And then it says something and states that for any value k, and this is a little bit different than the way we were phrasing it, any value k in the interval, so in this interval that they gave you, there exists a value c where, they're using where instead of such that, and then you want to tell them what the y values were that they gave us. So that's between 5 and 2. So -5 less than c less than -2. Such that f of c equals k. And then they're going to give you some other information. So then they're going to say, oh, they ask, must there exist a value of c in the interval where f of c equals, oh, they're going to give you another question. So it says, must there exist a value of c in the interval from -4 to 4 where f of c, where f of c equals 0. And because that is between, is it between the, oh, I wouldn't say 0 in this case. I'm copying a different problem. So let's say f equals -3. And it would be yes, because not only is it between in here, but because we have all this guarantee of the IVT. So it would be C, so you would say there exists is the answer, okay? And then they pretty much give you the rest as a fill-in. All right, let's look at this last one. And this last one is an AP level problem. There's some goofiness stuff in here. You don't really need to worry about it. But it's good to see one of these off of a table because this is what we call a tabular stem, because this is the stem of the problem and it has a table in the stem there. So the functions f and g are differentiable. Just checking to make sure I'm still recording. So differentiable means continuous. You don't need to worry about that word right now. Just know that it means continuous. Eventually, you'll learn that along the way. So for all real numbers, g and g is strictly increasing. The table above shows the values of the functions at their first derivatives and its selected values of x. You don't need to worry about what derivatives means yet. The function given by h of x equals f of g of x minus 6. So we're supposed to explain why there must be a value r. So see how those words must be? That's an indicator that you've got an intermediate value theorem problem for between 1 and 3 such that h of r equals -5. So we're going to first of all state that we know that because it said that f and g are continuous, so therefore h has to be continuous. So h of x is continuous. Okay. And then we also need to do this calculation here of what the values are that are off with these r values, which are really going to be like x values. So I'm going to do that calculation off to the side here. So h of 1 equals f of g of 1 minus 6. So this is where the table comes in. I need to find g of 1 on the table. So g of 1 is 2. Now I need to find f of 2. So f of 2 is 9, and 9 minus 6 is 3. Now I need to find h of 3. And I have to make sure that -5 is between these two numbers. So f of g of 3 minus 6. So f of g of 3 is 4. And then f of 4 is -1. And good news, we know that -5 is between -7 and 3. So we're going to finish up this statement. So explain what, so h of x is continuous. So we would want to say by, or the IVT guarantees, actually, wait a second. I want to write down something else before that. And h of 1 equals 3 and h of 3 equals -7. There, the IVTs. Oh, we want to write since. There. The IVT. The IVT guarantees at least one value, I'm putting this in the context of the problem, R, such that h of R equals -5. It's continuous, I missed the interval, so on 1 to 3. Should probably make it closed. Such that h of R, because, and then we want to put -7 is less than -5 is less than 3. And that concludes the lesson for the day.